The topic of this video is volume, and we're being asked to calculate the volume of this drink bottle. The drink bottle has a radius of 4.3 centimetres and it has a height of 17 centimetres. The shape that we're looking at is a cylinder, or I like to call them a circular prism. So the prism formula applies. So the volume is equal to AH, which the area is a circle, so that's the area of a circle, which is pi r squared times by the height of the prism. So that's pi times 4.3 centimetres squared times by 17, and that turns out to be 987.5 cubic centimetres. And as you may have learnt before, 1 mil in capacity is equal to 1 cubic centimetre of volume, so you could say that this will hold about 988 mils. The actual flask that I measured this on was rated as 1 litre, which is 1,000 mils, so we've gone pretty close. The second question is calculate the volume of a swimming pool, and it's a swimming pool that has a shallow end and a deep end. Now, the end of this shape, which I'll just colour in a bit, alright, that's the end of the prism. We need to acknowledge that that's a prism shape, and this is the end of the prism, and this distance along here is the height of the prism. The end shape is actually a trapezium because these two sides are parallel, and this side here is actually the height or the distance between those two parallel sides, and this side here, this sloping one, we just won't need to use at all. So because it's a prism, we can use V equals AH. And what I'm going to do, because we're going to end up with two heights here, I'm going to put a P next to that H to say it's the height of the prism. Now the area of the end is a trapezium, so that's a half A plus B times by H, but that's the height of the trapezium times by the height of the prism. A little confusing, but nothing too drastic that we can't live with. So that's a half times 2 plus 1.2 times by the height of that prism, which is 25 metres, times by the height of the prism is 10 metres. Now, multiplying that out, this turns out to be 1.6 times 25 times 10, and that turns out to be 400 cubic metres, because all the measurements were in metres. Now, 400 cubic metres is just a number, but when you think that what a quantity of water, the capacity of water that it would take to fill this, that I'll have to write that up here. That's going to be 400 kilolitres, because 1 cubic metre is the same as 1 kilolitre. Or we could also think of that as 400,000 litres, which is a lot of water. The third question, we're after the volume of this shape, and this shape is a cylinder with half a sphere on top. A half a sphere we could call a semisphere or a hemisphere if you're thinking of the Earth. So that means the total volume here is equal to the volume of the cylinder plus the volume of the semisphere. So We know that the volume of a cylinder is pi r squared h. It's a prism, so this first bit is A times h, plus the volume of this semi-sphere. Well, we needed a half here because it's half. Okay, we need to sort that one out. It's the volume of the semisphere, which is half the volume of a sphere. And a sphere volume is 4/3 pi r cubed. That's one of those formulas that you need to learn, I would suggest. So this is pi times, now the doesn't say this precisely, but 12 here is the diameter. So that means the radius is 6 meters. So this is pi times 6 squared times by the height of the prism, which is 15, plus a half times 4/3 times by pi, and r is 6 again, so that's 6 cubed. So this comes to 1696 plus 452, which gives 2148 cubic meters. Now, I don't know what sort of structure would have this shape, but to be 15 meters high, it's probably going to be a multi-story building, and 12 meters across. It could be something like a silo, a futuristic design of a building.